Okay, so looking at page 3 of the notes now, and what we're going to just talk about here are the chronological aspect of solids and voids, and how you can use the cut and don't cut tools so that if you have a void that is in the same area as two solids, you have a choice on how the solid is cut by the void. So I'm just going to go to the plan view here, and here's the initial rule about solids and voids. If a solid is created first, any void created after that will cut a solid if they share the same volume. So there's my solid. A little parenthetical note here. You can switch a solid to a void while you're drawing it. So I started with the solid tool. And while I'm creating it here, you can see in the properties palette that you can switch it to being a void. And if you started with the void tools from the void forms drop down, you're like, oh wait, I needed to create a solid. No problem, just go over to the properties palette before you finish, and you can switch it back to being a solid. So while you're editing a solid or a void, you can switch it from one to the other. So I'm making a solid first. So if the solid is created first, if a void comes after it, so on the Create tab, I'm going to make another extrusion here. So you can see here that the solid and the void are sharing space. And you can see that the void automatically cuts this solid. Now, if you don't want that to happen, from the cut menu, choose uncut. And then, it doesn't matter which order you do it in, you can pick the solid first and then the void, or tab select the solid, or tab select the void rather, and then the solid. Doesn't matter. Either event. Now the void isn't cutting anything. Now, if instead you wanted this void to cut the next solid, now because this solid was created after the void, Revit does not automatically cut the solid with this void, even though they are sharing the same space, and that's because the solid came after the void. So now we can use the cut geometry tool, and again it doesn't matter, pick the solid first or then the void, or the void first and then the solid, and now you can choose which solid gets cut by the void. If you want it to cut both, there's the void, pick the solid. So now that void is cutting both solids. So there's the cut and the uncut tools in that menu. Now, you'll notice that with the solids, you folks can see that there is a visible parameter, so you could turn it off if you wanted to. And there's a little gray checkbox here, which means that you could create a checkbox in your family so you could turn geometry on and off at will. So for example, in my exterior elevation here, these little fake lintels over this window, you can see here the visible parameter is kind of grayed out, and there's an equal sign here, and that's because if you hit the little gray box by the visibility parameter, Revit allows you to add a yes, no parameter. That is a checkbox. So here, head trim visible is a yes, no parameter that when you use it in a project, you'll see it like a little checkbox, and if this is turned off, then this solid is turned off. So the individual solids of your family can be flicked on and off as you wish. Not something you do very often, but we wanted to be able to use this design for this window, and if we didn't want to have these little fake glued on concrete headers and sills, we could turn them off when the design didn't call for them. Now the same cannot be said for a void. What if I want to make this void, on occasion, not cut these solids? Now, if you're wondering, well, when would I ever use that? Folks, if you go back to the week 3 when we did structural modeling, you folks will remember this beam family that we used. So in the structural exercise, when we did that sort of outdoor pagoda thing with the 4 wings on it, and there were those beams that we drew, that if we used them in a project, we could, oh, that's not what I wanted to do. So I'll just jog your memory here. So I'm just loading this beam that we used that night into a family. Okay, so here's our beam. And sometimes when we use these wood beams in a project, we like to sort of create a little angled cut on the bottom. And so there are parameters here somewhere in this thing. There we go. And so these parameters here, you can see, create those cuts on the ends of the beam. How is it then that I can make this void appear or disappear? It doesn't work that way. Instead, what we have with this family so the beam, the main part of the beam is this rectangle that's in the center. And you folks saw it in 3D, so there it is there. There is the beam, and there's the 2 voids. So what this family does is we have parameters right here. See this reference plane? This void is attached to this reference plane. And if this reference plane moves in close enough, it will cut the solid that is our beam. So what we have is a yes/no parameter that if we want the beam cut, so if cut N1 is checked, so in family types here, you can see there it is, notch N2, notch N1. If these are checked, then what happens is this family sets this value here to 0. The void comes in, cuts the beam. But if you do not want that void to cut the beam, so you want a straight cut at the end of the beam, it's turned off, then what Revit does is it moves the void far enough away from the beam that there's no chance of cutting it. Now this void isn't going to cut anything else in your project. A void in a family will only cut geometry in the family. So in this case here, that beam with end cuts, it's in tonight's folder as well. Anybody here know about if, then, else? The logic that's used in basic computer programming. So if, then, else. Revit has that functionality built into its families, and you can use it in some very basic ways. So these are the yes/no parameters here. Notch N1, notch N2. What you see down here are a couple of length parameters. So I ran a dimension from a reference plane that I drew past the end of the out-of-the-box timber beam family. Drew a reference plane here and a reference plane here. I don't even know what these other reference planes do. It's just like whatever, it's Revit's stuff. So this length parameter here all it does is it grabs this reference plane and slaps it right against the edge of the beam, or pulls it back so that the void has no chance of cutting the end of the beam. So inside family types, yes, no is really like a binary 1 or a 0. So in terms of logic, checked is yes, unchecked is no, checked is 1, unchecked is 0. So now we have a dimension parameter. Now look how this works. If notch and 1, so the way the syntax of this works is, in Revit, if it's an if statement, value if, or no, this is the test. So this is the test, then a comma, value if true, value if false. So if notch and 1 is true, make the value of this dimension 0. If notch and 1 is false, therefore unchecked, make the value of this dimension a value that's large enough that it moves the void way past the end of the beam. So the 100 millimeters is just some extra clearance. This parameter here, n cut back, is what defines the length of this triangle that cuts. That's end cut back from here to the point of the void, and we can have a look at it. Right? So that just defines the amount of rake. So if I want that thing to go back a foot, and cut back a foot from the end of the beam from here, a foot back, and then up again. So I've got a couple of dimensions here that just define how much of the uncut edge at the end of the beam I have, and how far the cut back goes into the bottom of the beam. So, in family types, what I've just done, if somebody does check notch N2, so if it's true, so yes, notch N1 is, oh my gosh, major logic error. Void engagement 2, notch N1. Yeah, so really this should be void engagement 2, notch N2. It doesn't really matter. Well, yeah, it does matter. Yeah. And we're recording this on the internet. So you guys can see how this works. So if that's kind of interesting to you, read up about how the if statement can be used in Revit. This is a classic example of how that works. So that's what moves those voids in and out from the end of that beam. Okay. Now we're going to go back to the window family we've been working on here, where we've got these voids. And we're just going to talk about how you can constrain your circles. So if you've got a circular geometry that you're building inside a family, and you want to sort of put it somewhere so that its location can be defined. Now this would be something that you would do inside an extrusion sketch. So here, if I want to make this circular geometry, I want to keep it aligned, say, to this reference plane, you need to do that while you're editing the extrusion. For whatever reason, being inside the extrusion sketch just makes this thing more pliable. So now let's look at circles, page 3. So you can constrain to quadrants or to the circle, the center of a circle, inside your sketch. So let's just show you how here. So you've got the dimension command activated, and from your reference plane, so there's the first click, and so my second click, I can either make it to the near quadrant, so it doesn't give you a quadrant snap, but when you click the near quadrant, you can see that the dimension snaps to it. Or I can click to the far quadrant. Now here's where it gets a little weird. If you don't click to the near or far quadrant, if you click sort of in between here, you can see that you get a center snap. So if you go to one of the sort of half quadrants here, it'll snap to the center instead of one of the near or far quadrant. So you can decide which of those that you want. So you can now constrain the center of the circle. So at the center of the circle is maybe at the driven by some distance from the reference plane, or you can dimension to a near quadrant, and so this would allow the edge of the circle to be constrained to a reference plane. And we will be doing this in a few minutes when we make a round window. Now with an arc, I'm just going to delete the circle here. With an arc, it's actually super easy because the endpoints of the arc are kind of sticky. They will tend to stay stuck to, say, a reference plane that it intersects. So again, I'm in the plan view of this window, and there's these two reference planes here that I'm just going to demonstrate with. So if those reference planes were to move around, we would be able to, that arc would stay stuck to it. So as those reference planes moving back and forth, you don't have to worry about, you know, using the align command to align this, the end of this arc to a reference plane. It'll just move with it. Now what you may decide you need to do is to define the height of the arc. So if I want to keep the top of a window at a constant height of curvature, the radius probably doesn't really matter to us, but the height of the curve probably does. So you can just run a dimension from a reference plane at the top of your window to the apex of that arc. So that dimension can be made parametric. So if you want a constant 4 inches of height for that arc for your windows, so if you have a 4-foot wide window and you have a 2-foot wide window and you have a 6-foot wide window, but you want the height of that arc to be consistent between them, obviously they're all going to have different radii, but you want that height of the arc to be the same, no problem. You can just run a dimension on it and it works just fine. On page 3 there is a radius that relates that height of the arc, h, to the width of the arc, w. So I know there's some people who've used that in the past, so I just put that in there for your reference. So now we are going to build a window on page 4, and we're going to use the face-based window template. Now, okay, so we've got this window here. In the session 6 folder for tonight, I've got there's a project in there. It's called, it's massing. It's a massing project. Oh, here, massing project. You see it here, massing project. So we're going to open that up. And this has some walls that have been placed using the wall by face tool to create a wall that is curved in 2 dimensions. So if you folks remember from, I think it was week 3, where we talked about the massing tools and how you can build a mass form, and then you can use the wall by face tool to skin a wall onto the face of one of these masses. Now what I'm going to do is I'm going to insert this window into the face of that mass, and you can see the result. Now when you use the window template, the resulting window will always be vertical. So this window here, I'm going to load it into my massing project, and I'm going to put it on the wall here. Now on the one hand, you can see the walls, it's curved in both directions, and as I put this window in, it does respect the plan curve of the window, but because, you know, at different locations here, this, you know, it's sloping backwards, you can see that our window just pays no attention to that, and the result is a little bit hilarious, right? So if you folks have the good fortune of working in an architectural firm where you get to do a wall that slopes out, or it's got a double curve in it, the regular window tool is just not going to work. So we have to start with a different template. So what we're going to do now is we're going to start a new window family. All right, so let's go to the File menu and then hover over New and then choose Family. Now, out of the family list, we want generic model, face-based. Now, this is actually calling for metric, so we will start with the metric template. If you're not seeing any sort of metric in here, then what we have to do is we have to go back out one folder and go into the English folder. Now that you're in the English folder, you can do the metric generic model face-based. There it is, right there. Metric generic model face-based. Now, this is a very special family template for a couple of reasons. Number one, this family can be inserted into anything in Revit. It can be inserted into a ceiling, can be inserted into a wall, can be inserted into a roof or a floor. So walls, floors, roofs, ceilings, this thing will stick to the face of all of them. The other great aspect of using this family is that where these two reference planes intersect, that's the insertion point for this family, and it will insert itself at the normal to the insertion point. So that means on our funky double curved wall here that wherever we put this window, it's going to stay normal to that surface, insert itself so it's perpendicular to its point of tangency. All right, so, but yes?
If you accidentally select the wrong family, and can you change the incision different face? Let's say you put the face-based family.
Yep.
And then can you change back into wall-based family?
No. So you are committing yourself when you're using these templates. So when you are in the new family dialog here, when you have one of these, floor-based templates and you start with that, you're committing to that direction. This family will only insert itself into a floor. The face-based template is unique that it will allow you to insert it into all different kinds of objects in your project. Now, this is generic model, so the first thing we need to do is switch its category. So you got to go up to the family types dialog box, the one with the little yellow folder on it. So you can see it's generic models right now. We're going to scroll down to Windows and hit OK. So now, from this point forward, Revit says this is a window. Now what we're going to do is we're going to add one reference plane that's going to be the hinge point for a big shutter that's going to go over this round window. So from the Create tab, find the reference plane tool, not reference line, reference plane. And we're going to insert a reference plane that's about 800 millimeters from the insertion point. So if you just move your cursor down until you get to 800, there you go, and just draw it horizontally. Now we don't need to name this reference plane, but what we do need to do is create a hole here. So this thing's going to cut a hole through our whatever, wall, roof, floor, when we insert it into the project. Now, if we go to the Create tab, you folks will notice that the opening tool isn't available. So we can't actually cut an opening. Well, we can. We just have to use a void instead. So from the Void Forms menu, grab the void extrusion. And so what we're going to do is we're going to create a circular void that's going to cut through this little extrusion that we're seeing here. So what this extrusion represents, that's provided in the face-based template, it represents the face of an object. So it could be the face of a wall, the face of a door, and it represents the insertion face. So if you're on the exterior part of your wall and you insert it there, that face that we're looking at right now would be the face that you would see in your view. So if you insert from the outside of the wall and you insert it, that's where the window will go. And then, of course, if you flipped around in 3D and looked at the inside face of your wall and you insert the window there, that's what's going to happen. So it depends which face that you're looking at when you insert your window. Okay, so there's the circle tool. And what I'm going to do is I'm going to take the circle up until it touches that reference plane. So this void is going to cut through our host geometry here. Yes?
About the faces, is there a way to determine exterior and interior for the window if it's space-based? If you want to leave it.
Yeah, no, I don't think we'd be able to create, it doesn't look like we can put the controls on it. We might be able to put it on in plan, but I don't know if we'd ever see them. That's something we can look at. No, you can see the controls aren't available here. We might be able to right-click and flip face once it's loaded into the project. We can check and see if that works. Now, what we need to do is make the extrusion big enough so we know it's going to cut through a wall no matter how thick it is. We'll do that in a moment. So just ensure that you've created a void. Make sure it's not a solid. And then hit the green check mark. So now what we're going to do is we're going to go look at it in 3D. And there's our void. Now the scale is a bit crazy here. It's 1 to 100. I'm going to switch the scale to 1 to 10. So you can see there's our void. So I'm just going to select the void and I'm going to drag the handles up and down so that we know here it's going to be deep, or it's going to be a big enough void to cut through, 2 meters thick of wall, 6 feet. That's going to be fine. Now you can see that the void is not yet cutting our little host wall here, our host geometry, so we've got to use the cut geometry tool to make that happen. So in 3D, grab the cut tool, and again, it doesn't matter which order you do it. So now we have our hole being cut through whatever object we're going to place this window into. Now I just realized I forgot to put the dimensions in. Let's go back to the plan view. So it says ref level. And let's put our cursor on the edge of our void here and edit it. Now if you look on page 4 of the notes on the left screenshot there, there's three dimensions which have been placed. Now you can see 2 of them go to the quadrants, and what they're meant to do is to keep the center of the circle over top of the intersection of these 2 reference planes. Well, I've done a lot of testing with this family over the years. The only dimension we need on here is a radial dimension. So if you folks want to go to the dimension menu drop down and grab a radial dimension, and we're just going to dimension the radius of our window, so there it is. And we need to make this parametric so we can change the radius of our window. So I'll hit escape twice and then select our dimension and hit the little new parameter button so we can create the opening radius parameter for it. And once you've labeled that dimension, you can go ahead and finish so that your void is complete. So we are on to page 5. And we are on step 6. You guys don't have to read the notes. You can just come back and refer to them later. I'll follow the notes here as this is going up on YouTube. Okay, so right or left elevation, I think I will go to the So I'm in the right elevation. It doesn't matter what you folks decide you're going to do. Now remember I told you guys about the different reference planes for the outside of the window frame and the inside of the window frame, and then the glass somewhere in between. So that's usually how I draw my windows. So what we're going to do is we're going to draw these three reference planes in right now. So the exterior of your window will be represented by what's kind of on top. Now, this template's a little weird. When you build a window family in Revit, usually it's built in elevation. There's a piece of wall that's given to you and it's standing upright. You build the window standing up. In this family template, you're building the window as if it's lying on the floor. This thing here, this little sample piece of whatever, represents the object that you're going to insert this window into, is flat on the floor. So you're kind of building it this way. So when you're looking down on it, that's the exterior face of your window as you construct it. So the interior face is on the underside. So we're building this from the top down, as the top being the exterior side. So here goes the three reference planes. So again, reference planes, not reference lines. I'm going to draw three reference planes horizontally. One just above the extrusion, one just below the outside face, and then one more farther down still. There we go. So we've got those three reference planes that we are placing. Now, we need to name two of them. The top one, the top reference plane, is going to be the face of frame. The next one down is going to be the face of glass. Face of glass. And the third one doesn't need to be named at all. So the design of this window is such that the frame of the window is going to be just slightly proud of the face of the wall. So you've got those three reference planes placed. So now we need to throw on some dimensions so that we can control how far the frame protrudes from the wall, how far the glass is inset from the face of the frame, and then finally what the whole thickness of the window frame is front to back. So we're just going to grab the regular aligned dimension command here. Now firstly, what we need to do is make the dimension from the outer reference plane, which represents the exterior face of our window frame, and dimension from there back to the face of the wall. So now we will do a dimension from the exterior reference plane down to the glass reference plane. And the third reference plane will be from the front to the back. Yes?
Just dimension from the face of...
Yeah, so this is from the face of the frame to the outside face of the wall.
Does it mean we're going to change the location of face of the wall, or the face of the wall is fixed?
Exterior face of finish in your wall. That's what it will be.
So it's fixed, so it doesn't matter if you do that, if you just
Yes, it's fixed.
dimension from the wall to the... does it make any difference which one is first? That's my question. For the changing of the reference planes, does it matter if you dimension from one to another, or the other way around?
No, the direction doesn't matter. So if you dimensioned from here to the reference plane, if you do it in that direction, or if you do it the other way around, doesn't matter. Same thing. Yeah. Okay, so what we need to do is give labels to these dimensions so that when you're using it, you can control all this stuff. I'll start with the one here for my front to back. So this one here is going to be window frame depth. Window frame depth.
Would it make a difference to dimensions between the level or the reference plane in that same?
No, either way, this will represent the face of the object. Yeah, and that's good. I'm glad you observed that. So the point is that when I did that dimension, I could either dimension from the level to the reference plane or from the face of the extrusion to the reference plane. Both will have the same results in this case. All right, so the next one is here from the reference plane for the outside to the glass reference plane. So we're going to label that one, and we will call this glass setback from frame. Okay, and then finally this last dimension here, which defines the offset from the exterior face of the wall to the frame. The label for that is face or frame offset from wall. Frame offset from wall. Now if you look at the notes here, you can see that the frame offset from face is 100. So to make that happen here, you slow double click your labeled dimensions. 1 click, 2 click. So it's 47 now if I put in 100. There we go. Frame setback, or glass setback from frame is 40. So 1 click, 2 click, 40. Window frame depth, 186. I want it to be 250. Click once. You can see it turns blue. Click on it again. You can change the value. Now this, of course, what I'm doing by selecting the dimension to change its value is something you can't do with a dimension, ever, unless it's labeled. So when you're working on a family, when a dimension is labeled, you can actually click on the dimension and change its value, which is a unique feature of dimensions inside families. Now the next thing that we need to do is create the frame for the window. So we're going to go back to the ref level floor plan view. Now we're going to build the window frame, so of course we need to use the set work plane command to set our working plane to our frame reference plane. So create and then set, and from the drop down menu find your whatever you called the face of your window frame. If you don't see it here, you got to go into elevation first. So I'm just going to cancel out. You have to go into elevation and just click it and give it a name like face of frame. So if you've forgotten to do that, do it now. After you've done that, make sure your glass reference plane has been named as well. All right, so yeah, create and then set. So there's my face of frame. Okay, so we're going to do the window frame now. So we'll do an extrusion. Now, we're just going to talk here about subcategories. Subcategories are like the extra layers inside your families. So while we're just working on our window frame here, I'm going to go to the Manage tab and I'm going to go to the Object Styles dialog box. So this dialog box here is where you could, if you wanted to, you could add a new subcategory to your family. So there's the new subcategory button. So if I want to add something like the trim in, or we're going to build a shutter over our window. So I'm going to create a new subcategory called shutter. Two things. What this will do when you add a subcategory is that when you load it into a project, you can turn that subcategory on and off. And you can control its line weight independently from the other parts of your window. So that way you can control the line weights of your glass versus the line weights for the frame versus whatever else you might have in your family. You add a subcategory to a family, load the family into the project. The subcategories that you've added in your family will get added to your project. So then you can turn them on and off in all of your different views and adjust the line weights for it so you can fine tune its line weights when it gets printed. Okay, so I think I'm still inside the extrusion command. Now normally when you create your window frame using a regular window template, you could use the pick tool, locks enabled, and pick the edge of the opening. Does not work. Revit will not pick the edges of an opening created by a void. So there actually isn't an opening object there, it's just a hole through the extrusion, and Revit won't let you pick it. Sad face. So what that means is that we just have to draw the circle manually. So what we're drawing here is the outer edge of the frame. Now before I go any farther here, the subcategory setting here in the properties palette, instead of it being none, switch it to frame mullion, so it will be in that subcategory. Now once you've done that, you can go grab the circle tool and just put a circle at the center here where those two reference planes intersect, and just make it the same value as your opening. There you are. Now what I'm going to do is I'm going to use the offset command, and I'm going to offset it in by 100. Now be careful when you are offsetting. This circle that we've got right now is the outside of the window, not the inside. So you need to offset it inwards, not outwards, inwards. There we go. So you've got your two circles, they're concentric, subcategory is frame mullion. Now we want the size of our window to follow the size of that void, so we need to throw some dimensions on here to make that happen. So we need a radial dimension here. We're going to put on two radial dimensions, one to the inside of the circle, one to the outside of the circle. And once that's done, hit escape twice. So what we're going to do is we need to make the outer radius parametric. Now we've already created a length parameter that drives this value. So if you click 800, you'll notice that if you go into the menu, opening radius is already there. So you don't have to go and create a new parameter. Just click on opening radius and you're good to go. Now what about the inside? We can't take a regular length dimension like I was showing you with those windows earlier and run a dimension from this inner one to the outer one. Doesn't work. So that's why we created this second radius dimension to catch the inner circle of our frame. Now what we're going to do is we're going to select this dimension and give it a new parameter called frame inner radius. Frame inner radius. There we go. Now, wouldn't it be nice if we could tell someone, decide the frame width, and then we'll set the frame inner radius for you? Well, indeed we can. Here's how it works. Go over and open up the Family Types dialog box. So what we're going to do now is we're going to add a new parameter, a length parameter, that will allow us to define the width of the frame. So go find the little new icon at the bottom here. So we're going to create a new parameter called frame width. And you'll see it get added into the Family Types dialog box with a value of 0. So what we're going to do is we are going to give frame width an initial value of 100. So we're going to have a 4-inch wide frame. Now, what we want to have happen is for someone to define the frame width and have Revit subtract it from the opening radius to give us the frame inner radius. So we can make the formula do exactly that. So it's got to be case sensitive here. Opening radius minus frame width. So observe your spelling and your use of case. And there you go. So now you can see that frame inner radius turns gray, the value turns gray, because it's being driven by this formula. So the next question is, if I've got a parameter driven by a formula, it'd be kind of nice if I could hide it from the users. Because if this thing is sitting here, they're going to kind of think, hey, you know, I can modify it, but they can't. If they can't modify it, what's the point of seeing it? So what we can do is we can edit this parameter, and we can't so much as delete it as move it down to the bottom of the dialog box. Now, if you've misspelled one of these parameters, put your cursor in that row and then hit the pencil icon to edit the parameter. So if you've happened to misspell a parameter, go in, find the mistake, and you're good to go. Now what we're going to do is we're going to change the group that this parameter is under. So you can see each of these different sets of parameters are under a group, this blue heading bar. What I'm going to do is I'm going to group this parameter under Other. So what this does is it moves the dimension from up here and sends it way down to the bottom of the dialog box where it will probably be ignored, which is fine. Because people don't really need to see it anyway. They need to just work with these other parameters that we've provided. All right, you can hit OK. So now frame inner radius will be driven by opening radius by minus whatever frame width we specify. Now if you've got your subcategory set to frame and mullion, the only thing we need to do now is add a material parameter for the frame so that when we render it, we can control its material. So hit the wee little gray box here, and at the bottom here we're going to add a new parameter, and we're going to call it frame material. Hit OK, and then hit OK. And now you will see that the material parameter is grayed out. There's a little equal sign on the box here, and we're actually we're finished. So hit the check mark. Yes. Okay, I will come back and have a look. Oh, I just realized, boy, that's really messing up the proportions there. It's not very circular looking, it's more like an oval. Oh well. It's fine on my screen, and it'll look fine on YouTube as well. Okay, so what we're going to do now is we're going to look at this thing from our left or right elevation here. Now you can see that the extrusion is going in the wrong direction. It indeed is emanating from the proper reference plane. So what we've got to do is select our extrusion, grab the little triangle at the top middle, and drag it down, 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 and touch it against the reference plane that we created earlier. You'll see a lock icon appear. Click it. So now our frame is complete. Need to do the glass now, so we're going to go out to our reference level floor plan. And we need to use the set work plane tool so that we are putting the glass on the right reference plane. So go to create and then choose set. So in this case, you're going to choose your face of glass reference plane. There we go. And we're going to create another extrusion. This time what we're going to do is make the extrusion end value minus 75 so that it, oh that's too big, minus 50 would be fine, minus 50. So it's going to go back into the window. So if we made it a positive value, it would extrude towards us. We want it to extrude farther back into the frame, so we're giving it a negative value. Not going to worry about making it parametric. Subcategory, switch it to glass. So extrusion end is minus 50, subcategory is glass. Set the work plane to your face of glass, and then all you have to do is use the pick tool and pick the two edges of your inner frame. And that's it, you're done. So when we look at this thing in 3D, let's turn shading on here. So shaded. So now you can see the window frame and how far it's sticking up out of the surface of our host. Now I've got one little tricky bit left to do, and then we're going to move on. So we're going to go into the right elevation now to work on this, and I would suggest that you set the scale down to 1 to 10. This will just allow the text of the dimensions to be a little bit smaller so that it doesn't get in the way. Oof, that glass is looking kind of thick. I'm going to make it minus 25 instead. There we go. Okay, what we're going to build is a little hinged part of our window. So if you folks are getting into renderings and you'd like to make, say, the vent frame on your window, whether it's an awning type window or a casement window, you'd like to show the operable part of your window hinged outwards for the rendering. So it kind of gives your building that lived-in look. You can use this process to make that happen. And we're going to do it here using reference lines instead of reference planes. So if you folks go to the Create tab, in this case we are going to use the reference line tool. Not reference plane, reference line. Now the difference between these two, reference planes will move perpendicularly to their direction, and quite happily too. A dimensioned reference plane can be moved just fine, but a reference plane hates being rotated. And in fact, it will generally really resist that, even if you try and put some angle parameters on it. It just doesn't like it, and it's not designed to do it. Reference lines are designed if you need to make hosted rotating geometry. So there's the reference line tool. So what I'm going to do is, I'm on purpose not going to draw it right at the corner. I'm going to come over a little bit and go up. And I'm going to come up, say, 50. And I'm going to keep on going with my next reference line on an angle of some kind. So we're going to have two reference lines, just like that in the right elevation view. Make sure that that reference plane at the edge of your window is visible. So this is going to be the hinge for the shutter that goes over our window. Okay, so we're going to grab the dimension command here, make sure it's the aligned dimension. And with this aligned dimension, we're going to go from the reference plane at the top of our window, not the extrusion, the reference plane. So that's the first click. The second click will go to the intersection between those two reference lines. So hit escape a couple of times. Pick that dimension you just created, and we're going to make a parameter call it for it. We're going to call it hinge length. Now we could model the hinge, make a little extrusion here in this view that kind of models the hinge that's going there. But that's all we need to do for now. Now, one more dimension that we have to add, and you have to be careful about this one. It's going to be an angular dimension. So grab the angular dimension from the menu. Now, you must click first the reference plane at the top of the window. You must not click the extrusion first. You must click the reference plane. Click that first. Then click our reference line and place that dimension somewhere. Okay, hit escape a couple times. Now what we're going to do is we're going to use the align command so we can get this hinge right here at the reference plane. So there's the align command. Pick the reference plane, the reference plane, and now the reference line, and lock them into place. You'll notice that the hinge length value changed. I'll hit escape 2 times here. So I'm going to slow double click on hinge length again and return it back to a value of 50. There we go. Okay, the next thing we need to do is we're going to make the angle parametric as well. So click on our angular dimension, and we're going to go up and add a new parameter for it. So we are going to call this, in the text it calls it flap angle. You can call it that if you want. I'm going to call it shutter hinge angle. Now the really important thing here is not the name, it's that we are making it an instance parameter. And the reason that we're making it an instance parameter is so that each time we insert this window, that value can be changed on each window individually. So you'll see what I mean in a few minutes. So now I'm just going to make sure that if I change its value, nothing funky happens. Looks like we're all good to go. Great. Okay, if we look in 3D now, we should be able to see our reference line poking up there. So what we're going to do now is we're going to build the shutter so that it's hosted by this reference line. So you'll notice now that when I select that reference line, that it's got its different work planes there. 2 of them run along the length of the reference line. One that sort of goes horizontally, one that goes vertically, and then a work plane at each end. So what we're going to do now is we're going to go to Create and then Set. And we're going to choose the Pick a Plane mode in the Set Work Plane dialog box and hit OK. So we're going to move our cursor over so that it is on our reference line. And we want our geometry to be hosted by not that vertical reference plane, but by the sort of more horizontal one. So I hit the Tab key once. So that's what I want right there. So now I can left click it, and that is indeed where my shutter will be built from. So I can use the show work plane command to confirm, and we can just kind of orbit around here. I have no idea why Revit puts it on this funky angle. If you want to change that, you can tab select. Hold on a second here. Why can I not select this thing? I have to grab it by the edge? Maybe. Yeah, once I've selected the edge of the sort of sample work plane here, you can change its size. You can drag the little dots to make it bigger or smaller. And I can rotate it. So here I'm going to drag my axis of rotation to here and rotate my work plane around so it's aligned with the reference plane, just so it's a little easier to look at. You don't have to do this. I'm just showing you that it can be done. So again, if you pick the edge of your work plane after you've shown it, you can rotate it or you can move it so that you could, in this case, align the grid on the work plane with whatever it is that you're building. I have a keyboard shortcut so I can toggle the appearance of the work plane whenever I want to see it. I also have a keyboard shortcut for the set work plane tool because I use it so frequently when I'm building families, and it just keeps me from having to go find it on the Create tab. Okay, we're going to do an extrusion. So Revit remembers all your settings from the last time that you did the extrusion. So in this case, I'm okay with the -50 value, but I'm going to give the subcategory here, I'm going to switch it back to shutter. Now, if you didn't build a subcategory for the shutter or for the flap, just set it to none for now, and that's fine. So what we're going to do now is build a circle, and the center of this circle is going to be on this reference line right along its length, and I'm going to draw it some distance away from the intersection of these two reference lines. I'm going to draw it more towards its end. Not at the end, but sort of close to it. And if you remember, the opening radius value I think was 800. So as I'm drawing the circle, I can just direct enter the starting radius for now. So there it is. And what I'm going to do is use the radial dimension command and just pick the circle. So there's my radius. And I'm going to associate this newly created dimension with the parameter that we've already created earlier. So hit escape twice. And now you can pick the dimension and go find the opening radius value out of the list. So there it is. Now what we need to do is make sure that the end of our hinge here is right at the edge of the circle. So this is a little bit of a funky step that we have to do here. So we're going to use the aligned dimension this time. And remember what we said. If you start at a near quadrant, well, first of all, we have to dimension from the intersection. So I'm going to start from the little dot here. So I'm going to tab until I get, now you can see if I start the dimension now by just clicking that green line, it wants to propagate perpendicularly from that line. So I'm just going to hit escape once. So I'm going to put my cursor at the hinge point here at the intersection of these two reference lines and tab until I get just a dot. Now you can see on my cursor it says intersection of reference lines. No, it's not giving me the, come on. Okay, maybe it'll be easier for me if I just start from the center of the circle. So to get Revit to start from the center of the circle, I put my cursor on the sides of the circle, not at the near quadrant or far quadrant. So that's the near quadrant, that's the far quadrant. So click here first, and then click on the dot, and there is my dimension. So again, use your dimension command, click on one of the side quadrants of the circle, click, and the second click will be right at the intersection. You'll get a little dot there, and you can place that dimension. Yes?
The reason we cannot actually select a circle when I'm trying to align dimension.
If you try to which?
If I'm trying to do the align dimension,
It should just work. If you're in 3D, if you put your cursor right on it, you won't see a snap. And then you click right here at the knuckle point, it'll just produce that dimension. Unfortunately, there is no snap feedback to let you know. Yeah, it doesn't give you any confirmation that you've selectively picked it, except that when you put your cursor, now look down here on the status bar. White space, white space, white space, clunk. So it is giving you some feedback, but just nothing right at the tooltip of the cursor. Anyway, that's why you guys paid to take the course, right? So now that we've got this dimension in place, you guessed it, we associate it with opening radius. And so what that does is it moves our circle right down to the edge of the hinge, and we are good to go. So just before you finish, make sure the subcategory is shutter. If you wanted to give it a material parameter, you could hit the little gray box and add a material parameter for it here, so I can call it shutter material. There we go. And I made the extrusion end value 50 to match the hinge value that we had. So there you go. So now we've got our shutter sitting on top of the our window there. So the last thing we need to do is save this. So I'm going to do a save as, file, save as family. So I'm going to put that in my, so we're going to call it portal window, and in the notes it says with flap. I'm going to keep my naming consistent here. I'm going to call it portal window with shutter. So now that we have this window here, let's look and see how it works. So what you folks need to do after you've got it saved is open up the massing project. So I've already got it open here. And with those original 313 windows that I had modeled earlier. So I'm just going to Control Tab back to my window here and load this thing into the project. So now look what happens. You can see as I'm putting this window in, it's following the normal of the curve. So I'm going to put a few of these things around. So each one of these windows, you can see it's following the curvature of that wall because we built it with the face-based template. I'm going to delete these other windows here. Now remember that shutter angle value that we gave, it's an instance parameter. So it means when you click on the window, it's right here. So it means that each window can have its own unique value of the shutter hinge angle. So some of them I can make open quite a bit. Others can be opened a little bit. So imagine that you're doing a house rendering and you want to show some of the windows open or some of the vents open on some of the windows. So you could build your windows so that the vent frame is hosted on a reference line, and you can make that reference line angle outwards to represent a operable window. Okay, so if you folks want to save that portal window to your own folder and have that ready and just share it in to your share in folder before next week. Now, last week we talked about arrays in families, and we made that louver that had the multiple blades in it that you could get Revit to array as needed. What I'm going to show you folks now, just opened up the wrong template here. In our Session 6 folder, I've got a series of what are called two-pick families. Now, when you're building your own families, you'll notice that in the family template list, and I've mentioned this a couple times already, we've got line-based families. So there's your detail item line-based, and here's generic model line-based. So there's these two templates provided, one for doing repetitive drafting work, and generic model line-based for doing, for drawing objects whose length is variable. So, any of you who've done a bit of work with drawing cabinets, you often know that when you have some cabinets and then there's a space between the end of the last cabinet and the wall, the mill worker may provide a little filler piece that just goes in at the end. It's got its own little kick at the bottom. And this thing's length will be variable. Now, what you can build using this generic model line base is to start off with that template, switch it to the casework category, and then define an extrusion that you'd first build it in elevation, and it would look like this. It would have that sort of Z-shaped piece here with the kick and piece going out. So that's what it would look like in elevation. And what would happen is that when users place it, there would be 2 clicks that they would place. And those clicks could be any length apart. It could be, 10 inches, it could be 1.5 inches. But with these line-based templates, you can vary the length that they draw, that the user draws on the screen, 1 click, 2 click, and it will create this stretchy family that will go in between those 2 points. Now, what Revit users have done over the years is they've commandeered this family. Maybe that's not the right verb to use, but they've used a two-pick family for repetitive work of another kind. Now, back in the earlier days of Revit, when we needed to do things like lay out chairs in an auditorium floor plan, or lay out parking stalls, you had your first parking stall that you put down, and maybe you used the copy command and copied it a bunch of times, or maybe you used the array command and arrayed it a bunch of times, so that you could get your count of all the parking stalls that you would use to pave paradise. So, parking stalls are a fact of life. So, rather than that tedious process of arraying them in your site plan or copying them around, however you want to do it inside the project, somebody got the great idea that they'd start off with this generic model line-based template, and they would load in a parking stall. Then what they did, so if we look at the generic model line-based template, just to see what it looks like, there is this length parameter in it. This length is an instance parameter, because every time you draw it, it's going to be unique length. So here's click number 1, here's click number 2. So in the case of that filler piece of cabinet, you'd be looking down on it, and you'd see a sort of little thin extrusion that you'd be drawing, because if you look at it from the side, that's where you would draw it with its height, width, and the kick, right? You draw that in a side elevation. And that elevation will just stretch for as long as the user clicks. Click number 1, click number 2. So the secret sauce here with the parking stalls is that you put your first parking stall at the beginning here, and then you get Revit to array it parametrically. So you have as many parking stalls as you can fit between those 2 clicks. So here I don't have, there's not enough distance between these 2 clicks to get in the 5th stall, but if somebody actually clicked a little bit farther, hey, you know, that'd be enough to get in the 5th stall. So what we use is the line-based family template in conjunction with another family that we load in and nest it, and then we array them. Now, in the case of a parking stall, we want to slap those things together as tight as we can. So we will do parking with a second type array. Now, if we're doing something like a chair, the exact spacing between the chairs doesn't matter. What we want is that at the first click and the second click, we get a chair. So here with the parking stalls, if we don't get to an exact increment of the parking stall width, doesn't matter. We just want as many stalls as we can fit within the 2, but still providing the full width of the parking stalls. With chairs, you know, if it's 1 inch out, 2 inches out, it doesn't matter. Just as long as it's wide enough to get that chair in there, we want chairs. So in this case, chairs, because it's not a precise, you know, dimension from one chair to the next, we make that as a last type array. So we're going to look at those 2 different families now. And these are already provided for you in the folder, so you can just grab them and use them. So I'll start with the parking first. So here is this family in all its glory. So we brought in the parking stall, and we did the array command. So the second type array. So the first and the second member of the array drove the spacing of all of the rest of the parking stalls. So if it's a 9'6" wide stall that you need, that's going to be, you know, the spacing for each one of these. Now if we contrast that with the chairs, so this one, there's the first pick, there's the last pick, and Revit just fills the space in between with an appropriate number of chairs so they're at least not overlapping and not over top of each other. So this was done using the last type array. So you can dig into those, you can kind of play around and see how those values worked. Remember last week we talked about integer values or integer parameters. And so if you make an array in a family and then you click the connector that defines the number of objects in the array, click on that connector and assign a parameter to it. It's an integer parameter that drives how many objects are in the array. So in this case, the spacing that we want, or the number of chairs we get, is the length divided by the rough chair spacing. So here I've said we want roughly 2 feet between the chairs. So it takes the length of the line that someone draws, divides it by the rough chair spacing that we want. So you have to kind of think about, you know, how much space you need to get a chair and someone's butt into a space, and, you know, use some sort of reasonable nominal value for that. You'll notice the +1. That's because, of course, if I've got a 10-foot space, yes, that gives me 5 spaces, but then I also need 1 at the end. So that's why it's, you know, whatever chair spacing we want, divided into the length +1 at the end. So that's the value there. When we go and look at the other the parking stall family, the number of parking stalls that we've got, the number of parking stalls in the array is just the length divided by our parking stall width. There's no +1. It's just whatever. So if the user gets to, you know, an increment of our stall width, you know, 9'6", every 9'6", if you draw that line across the screen, you get an extra parking stall. So this is a really great, fast way to get your parking stalls put out on a site, and of course make your parking schedule, and Revit will count how many parking stalls you put into your project. So this is the family that it all starts from, this one right here, the line-based family. I'm going to skip along to page 9 because I want to move on here and give you folks a little bit of time at the end for questions and stuff. So what we're going to do is we're going to use this family right here, this line-based family, to make something that's array-based. Now what we need to do, I would suggest that you try and close down any files you're not working on right now so you won't have too many windows to jump back and forth between when we're doing this. Okay, so page 9, starting at step number 1 here. So we're opening a new generic model line-based family. So I've got that up on the screen. From the session 6 folder, open up the dental family. So what this is here is it's just a little rectangular block. So not much to look at in 3D. There it is there. It's just a little rectangular block. For those of you who don't know what a dental is, that's the spelling there. Dental blocks were used in, or are still used, I guess, in heritage architecture. So any repetitive little block form that's in a cornice on the outside of a building. So if you're going to build this whole thing and make a really sort of high-powered family, what you would do inside the line-based family is you'd have an extrusion that has the profile of this trim board here and the piece that's overhanging. So this whole thing would be one extrusion, but to get these blocks in place, you'd have to do an array. Now what I'm going to do here is I'm going to actually add in the two-pick family this extrusion, and then we're going to put the dental blocks in. Or actually we'll put the dental blocks in and then we'll build the extrusion. Whatever. You're going to see how you can have geometry that's in the line-based family, and then how we can nest in that array and make it happen. So let's do that. Okay, so there's our dental family. I'm just going to close it for now. I'm going to come back to our line-based family here. So what I'm going to do is I'm going to look at it from the right-hand side. So if someone was drawing a line across the screen, it would be right along this reference plane right here. So what we're going to do is an extrusion, and we're just going to draw it along the base here. So I'll make it say 1'6" tall, right to that intersection, and then I'm going to go up 1'6" as well, and it'll come out say 4 inches, and maybe down to say 1'3". I'm just drawing something roughly here, not too worried about how much precision I'm getting into. I just want to give it a little bit of a shape, sort of a cornice-like shape. So you've got the recessed trim at the bottom, and then I've got my overhang at the top. And now we're going to put our dentals right at the base of that inverted L. So this thing, this extrusion, is going to be stretched as long as the person draws it on the screen. So now when we look at it in plan, There's the extrusion right there. So what we need to do is stretch the extrusion over so it touches that reference plane. And lock it. So now when we look at this thing in 3D, this thing is going to stretch for as long as the person does those 2 clicks. So go back to the plan view here. Now what we're going to do is we're going to load in that block. So I'm going to go to our session 6 folder, open up that block. So there's our dental block. And I'm going to load this into that family I've been working on. So load into project. So I guess it's this family here. So whatever family you've got that you need to load it into. And there's my block. Now, a couple things here. I need to make sure I've got it in the right place. So I'm just gonna place one to begin with, and then have a look in 3D here. Now you guys can see that the dental block is actually buried. See it there? It's kind of inside. So what I need to do is I need to take that block and elevate it upwards so it's sitting on top of the extrusion. So I'm going to go to one of my elevation views here. See, folks can see where that dental block is sitting in elevation. Just went up and opened left or right elevation. So there's a few ways that you could skin this to make it work. Number one is you could use the align command. If I use the align command, then I'd have to pick the outside face of my cornice and then the bottom of my dental block. Now here, that's not it. I'd have to hit the tab key. There. Now I've got the bottom of that dental block and move it up and lock it. Okay, so again, in my elevation view here, your dental is going to be buried. So use the align command, pick the face of your cornice first, then go to the underside of your little dental block and hit the tab key once so that you grab the underside of the block, lift it up, and lock it. Then I'm going to use the align command again and grab the edge of the dental and pull it over to the underside of my cornice so it looks like this. Yeah. Yeah. So if you go to your right or left elevation, can you kind of see it kind of buried inside? Okay, now if you've loaded it into your two-pick family and you don't see it, what you can do is, like, maybe it didn't get inserted. So go to your families folder, expand it, go to generic models, expand it, find the dental family in the list, expand it, and the little child entry here that you see, drag and then release into the view, and then you'll know that you've got one here and you can place it. Oh, okay, so maybe your work plane's messed up. Let's have a look. No, you gotta be in the plan. Go to the plan. There you go. Now, yep, there you go. So yeah, when I'm inserting this dental, I'm in the plan view of my family, not in one of the elevation views. You won't be able to place it in elevation. So go to the plan view and then expand up the project browser and drag one of these things out and release it into the plan view. Having done that, then here it's on the left side, so I can move my left elevation and elevate that block that I have placed. So here I am, left elevation. There's the block I just added. Use the align command, pick the top edge of my cornice where I want the block to sit. Now if I did this, it would just take my extrusion, the bottom of my extrusion, and lift it up. That's not what I want. Tab key. There we go. And then lock it. So now in 3D you can see those dental blocks are both got their height where we want them to be. You only need one of them. Anybody need a hand? Okay? So now what we've got to do, again in the floor plan view, now that we've got our first dental block placed so its elevation is right and now it's tucked up against the underneath of our cornice, is we are going to use the align command one more time and align the left edge of our dental block to the starting reference plane. So you pick the starting reference plane first and then the left edge of our dental, and we'll lock it into place. So now we can do the array. So hit escape a couple times so you're not in any of the commands. And I'm going to pick that little dental block that we've created, and I'm going to use the array option here. It's going to be a last type array. So when you pick the array command, make sure you choose last as the mode. Click that anywhere, so maybe in the center of that block, and I'm going to on purpose drag it down on a bit of an angle like so. Now this is a last array, and the reason that we want to use that is so that the first block is constrained by its left edge, and the last block is going to be constrained to the right edge, to this reference plane here. So now that I've got this array created, I'm going to do exactly that. Use the align command. Pick that right reference plane first, then the right edge of that dental block, and lock it. And then the underside of where my cornice is going to be, and the top of that dental block, and lock it. So it means the first block and the last block will be right at the end. Now what we need to do, hit escape a couple times, we need to make this array parametric. So we select one of the blocks in the array. So this would be step 4 that we're at right now. But don't worry about following the notes, you can just follow on the screen. So we pick one of our dental blocks, and there's the array connector. So that little line there. So if you select either one of the blocks, you'll see the array connector between the two of them, and when you select it, on the ribbon, the label drop down will appear, and we can add a parameter now for the number of blocks that are needed for our cornice. So in this dialog box here, it needs to be an instance parameter, so do that straight away. It's got to be an instance parameter because the number of blocks that's needed will vary. Every time somebody draws this thing across the screen, it's going to be a unique number of blocks that are needed, so it needs to be an instance parameter. So this is going to be, for the name, number of dentals. So right now, its value is 2. So we need to go into the family types dialog box and get a formula going for the number of dentals. But really, first of all, what we need to do is to give our users of this family some way to control the spacing between those dental blocks. So we need to make a new parameter at the bottom, and we'll call this dental spacing. Dental spacing. Now this will be a type parameter because we'll probably have a nominal 1-foot spacing that we're going to use. So this doesn't need to be an instance parameter, we'll just leave it as a type parameter. So dental spacing as a starting value will be 1 foot. So the number of dentals that we need will simply be the length divided by the dental spacing. Length divided by, again, case sensitive, dental spacing. And there we go. So, in the notes, it says call it Tupic Dental Family, your last name, so I'll just do a save as here. Oh yeah, Tupic. So I use the prefix Tupic for these line-based families, so people know it's a two-click family. They're called Tupic families by Revit users, sort of on a more formal basis. So Tupic is kind of lets somebody know this is one of these sort of stretchy families. So Tupic dental, and I'll say dental with cornice. So if you look at this thing in 3D, that's what we're getting. So we've got a little bit of a cornice there, and those blocks are going to be arrayed as we draw this thing across the screen. Now, if you've got a project open that you could add this onto, actually, you know what I'm going to do is I'm going to add it to our massing project here. So I'm going to go back and open up the. So there's one with all the crazy windows on it. So what I'm going to do is I'm going to load this thing into our massing project here, and I'm going to go all postmodern on this thing. So here I can draw this thing on a face. So it's kind of like SketchUp in this regard. So now I can just kind of draw this thing right across from one side to the other. And underneath this thing, you can see it draws all those dental blocks in place. So just give that a go where you can kind of put it on a wall in your project. So here I'll use the align command. Yeah, good question. Someone might ask, what would I do if I want this family to miter at the corner? What you'd actually have to do is, in this family, you'd have to extend the cornice by whatever thickness you have at the top here. So if this thing was 1.6 feet wide at the top here, you'd have to build in your family that whenever you build this family, it actually extends at 1.6 feet past on both ends. Then you'd have to have a 45-degree void, which nibbles away right from the corner, right? So that extended part, there'd be a void that cuts it back at a 45-degree angle. Then when you build the next one, it just comes right to it. To be honest, a lot of people, when they do cornices like this in their projects, they often do them as a wall sweep. So the wall sweep will have the cornice profile, and then the dental blocks will be on their own as a Tupic family, just like we've drawn. So in reality, most of the times when I've seen heritage architecture done, the cornice was a wall sweep, and the dental blocks were added as a Tupic family, just like what we've done. I wanted to show you folks how you can make this stretchy extrusion so you understand the process of making a little filler piece for millwork, if you ever have need to do that in the future. Okay, so that is page 9 done. Last thing we're going to talk about tonight are swapping nested families. Now I'm going to close everything down here so I get back to the Revit desktop. Yeah? Save it in a library. So save it in a folder somewhere. So, and this is one thing that's good to remember as time goes on, you're going to download, and you're also going to build your own families. Now next week we're going to talk about sort of office organization, but I'll get ahead of myself a little bit here. All of the Revit families that you download with the software are in a folder buried deep on your computer when Revit installs itself on your computer. So as you are downloading your own stuff off the internet, it's a good idea if you make a folder somewhere on your computer that's got all of this stuff that you've downloaded. You know what, I'm going to do this someplace where the screen will get it picked up. So, make a folder maybe off your C drive or in your My Documents folder if you're a sole practitioner. In your office, you want to have a folder on your server where you can store all of this stuff in a dedicated folder somewhere so you can put this stuff, organize it, and keep it and use it in the future. So everything from, and you can replicate the Revit folder structure from annotations down to doors, down to windows. Kind of copy that same folder structure that Revit has, including detail items for drafting. And as time goes on, just keep on organizing and storing all of those families in a set of folders that you create so that you don't lose this stuff as time goes on. So you want to be kind of organized with this stuff so that you don't lose track of these families that you create. Now, what we're going to look at next here is using nested families, but multiple nested families. So in our session 6 folder for tonight, we've got an upper cabinet single door family. Now, if you're doing a fair amount of millwork, especially if you are rendering it, you've got multiple clients, and you're often using the same kind of designs for those cabinets. What this family has in it is a bunch of doors preloaded into the box. So we've got the, what do they call this thing? The back of the cabinet. There's a name for it. It's escaping me now. But the base cabinet itself, just with the top and bottom and sides and the back, that's been modeled, but not the door. The door is a separate family. It's been loaded in. And I've got 4 of them all loaded into this family. So we've got a flat door, just a simple slab door, got a shaker door, and we've got sort of a round top door with a bit of a profile to it, and a similar one that's got a glass door in it. So I've got these 4 different styles of doors. Normally what we would do when we build a family is we just do a save as. We'd make a separate family. So we'd have a cabinet with a slab door, we'd have a separate cabinet family with a shaker door, and so on. Now, instead of having 4 times as many families, what we can do instead is we can load all of these doors, build them separately, and then load them into the our box. And that's what I've done. So I've just nested them in. And I've placed one of the doors in place already. And this door has had, if you go back to our earlier videos, we've got the height and width of the door linked to the parameters inside this family that control the height and width of the overall cabinet, the overall width and height. So the door families which are nested in, this one that we've got, I've got its type in here, so height and width are nested to families in the, are linked to parameters inside this family, so when it's used in your project, users can change the height and width of the door. Great. But now what we can do is we can create a parameter that allows us to hot swap between the different kinds of the door. So let's look at page 10. So bottom of the page there, step 1. We're going to go into the family types dialog box here. So here we are in family types. And we're going to add a new parameter. So at the bottom here, add a new parameter. Now if you don't specify otherwise, Revit adds a length parameter to your family. What we're going to do instead is we're going to go down and choose the family type parameters. So what this does is it allows you to swap between different kinds of families. You just got to specify what category that they're in. So these are all casework families that have been loaded in. So we've got to choose casework in the list. So it's a family type parameter, and when we choose family type, it pops this dialog box up. So we know it's going to be a casework family. That's going to be swappable. Now, if we put it under other, it's going to be down here at the bottom. I want to put it up here with construction, so it's the first thing that people see when they open up this family. Construction. So now we need to put up here what it is. We're going to call it door style. Door style. There we go. So now look what happens. Now, in this menu, look at this, I can switch between the 4 doors. How cool is that? So this means now when I load it into the project, if I want an 18-inch cabinet, well heck, now I can also specify which door goes on the front of that cabinet. Now, the only thing is that I've made that parameter, but this door hasn't gotten the menu yet. Well, when you've got a nested family and you've made a family type parameter for it, and the parameter matches the category of this nested family, well, look at that. We can grab it out of the label dialog box right there. So you can see right now it's kind of that chateau style door. So I got to grab my nested family. There's my parameter for it. Boom. So in your projects, go into family types. Now you can make it a shaker door. So you can swap between all 4 different door styles in the context of your project. So what you need to do before next week is create those 4 new types using the family types dialog box here, and then using the new type option. So in this case, this would be shaker door. Now I'm going to make a new one. I'll call this chateau door. Oh, if I could only spell chateau door. But this one is going to use the chateau door. There we go. And so on. So just make the 4 different types that point to the appropriate nested door family. Okay, so that's it for the notes. The rest of it you folks can just read through. There's just some great stuff on shared parameters there. Just read that so you know how it can be used. And we'll leave the rest of the time here for questions and term project stuff that you may have questions about.
For your information, if you have not started your site plan, do not panic. Go ahead, proceed with your